Hello everyone and welcome to today's video. Here we're gonna talk about something that's not brought up quite frequently in the C++ community. One of the reasons may be that it's GCC specific and it is compiler specific, so that it's not frequently talked about, or it could be just that the evolution and modularization of C++ has increased so much over the years, and the language has improved so much that people just started using, not started, but kept using all sorts of specialized templates and stuff like that. So not a whole lot of people uh, really concern themselves about macros because, for example, inlining a function is as fast as a macro, right? So people just would rely on the compiler to make the best decision for them and their code, respectively. So let's just get straight to the point. The point is, in a statement expression in C++, GCC specifically, there is something strange happening, and that is that at the end of a statement expression lifetime, we make a copy because we need to construct a temporary object to hold the result of the statement expression. So as opposed to the function in C++, this is gonna make a copy, an extra copy, if you may. So I almost said coffee there. Pretty funny. But and because in C++, when you look at the function, this is resolved by something called copy ellipsis, if I'm not mistaken. C++ copy elision. I'm sorry. So it is resolved by copy elision. And that is when we eliminate essentially the unnecessary copy or move when we move outside of the function. We can demonstrate that in here with make s. So what is enforced here is a copy elision. So this is not the case for a statement expression, because typically statement expressions are used as part of macros. And people often miss this stuff. And a function is just so much different, obviously, than a macro, because macro replaces stuff at the preprocessor level. And it's entirely different. It just takes a piece of your code and cuts it and replaces it during the pre-processing time. So an example, like a primary example that I like to point out is when I try to, let's say, implement a short circuit evaluation in C or C++, but in C++ rather, I would say something like this: and operator left and right. And then you'd probably write something like this, okay, where you first it's gonna take a while to write this, but let's do it. Here we store the left. We can do auto there, right? Left. In C, you would probably do type of operator. it's become standard as of 2023, if I'm not mistaken. Um, then you have left here, and the reason why we need to store this in a temporary variable is that this can be a function, and once the macro replaces it, it's gonna be very, very sensitive, and we don't want to run a function twice. So what I'm trying to do here essentially is that I'm trying to implement this operation, this short circuit in C++. So the way I would do it is, now I take left and I say, you'd probably want to cast a boolean here. So I'm just gonna say static cast bool. And static cast is probably the one to use here because we want to detect some errors at compile time. So then we can return. So the problem with this C is that we need to return the value, and we can only return the value if we write a statement expression. That's why we came to all this point of, why am I making an extra copy out of my statement expression? But we'll get to that in a moment. I just wanted to compare these two. Let's say I wanted to write a function that does the same as my macro. It has left and right. So the way that function is so vastly different from macro in this case is that if I create, let's say foo, and in zoo, when I run a function, these two will be evaluated first before my function makes a call in the assembly. So we can see here that we first call the zoo, and then we call the foo, and then we make the actual call. But this is, I'm not gonna lie, a little bit strange. Why am I calling zoo first? Yeah, this essentially inlines everything, so it's not useful. Anyhow, that would be the way, and this is really not the short circuit evaluation, because we evaluate both of these values before we actually return our result here. But actually the logic of AND will be to return the right. I just figured that right and left. I wrote this as OR essentially. Well, now I'm curious. How are function parameters evaluated? C++, let's say, or C, whatever. So what's the order? It's unspecified. Well, I guess we'll cover that. I just thought it would be left to right, but yeah, it's definitely interesting. Anyway, So how my macro compares to this is that when I run foo here and zoo, I first I will run foo, and then I'll run zoo. And if the left is true, I'm going to evaluate the zoo. And the reason this works is that literally the compiler takes this piece of code and replaces it with in here. So it's quite literal. And that's the example that I wanted to show you, is short circuit evaluation and how macros are just so much different than functions. If someone may see, okay, why don't I just make a function? Well, not really. So to get to the point of this video, or get back to the point of this video, how are we supposed to avoid unnecessary copy here? Because we need to be able to just return s from a statement expression, even though it's lifetime ended. And there's no way for us to really prevent it from ending it, unless we wrap it up in a macro and then we return it. Well, if we still refer to it as this, it still would be copied. So what we're trying to do here is that we need to move this value. So that's where the answer lies, essentially. Is that literally we need to enforce the move, and then even though our temporary value might live in there in the statement expression, we are still moving it out of it. And we can see that in here. So we call the move constructor, and then we call the destructor of the statement expression, and then we call the destructor of the actual main scope, which is how it should work. So like that, we just removed our sort of concern. We eliminated the concern of the copy. For example, if this was a vector, std vector, and I had millions of elements that I created in my statement expression, well, it would be really, really, really bad. We can do some work to even not have this destructor. So let's do that real quick. And this is, by the way, covered thoroughly in the previous video, in one of the previous videos, and this video is called C++ hacking destructors. Feel free to check it out if you want, and if you got the time to. So I wrap this up in a union. So it will be S, and then what else do we need here? Yeah, we need the destructor of the union itself, which will be the inline, because we want to make sure it's not even called oh yeah, I just remembered. I don't think we can define a union in a statement expression. So there you go. Or can we? Let's see. Oh, was inline. Can we actually do that? Invalid use of void. That's fine. SS. And we'll do this. There we go. What about now? Alright, there we go. That actually worked, but we are having some issues, and that is understandable because we need to construct our S. Just get confused for a moment. I can expect most of the code to just work. So there we go. We effectively removed the destructor of the initial object. So we are not bothering to call or invocate the destructor at the end of its lifetime in the statement expression. This is really a hack, because we're like this. If you wrap your C++ user-defined values in a union, you will have to explicitly destroy them. Otherwise, they're just going to be left hanging. But since we are 100% sure that we're moving the value, we are confident that there will be no leaks. And to prove that, I will just show you the Valgrind output. So let's just start fresh, and let's just paste our code here and run it through Valgrind. So there are no leaks because we moved our value out of it, and yeah, there we go. So that's how you handle statement expressions in the C++ programming language effectively. You do not actually you do not need this union. It is just something extra that I added to avoid calling the extra constructor. But let's just revert this back to normal. Okay. And let's just test this for one more use case. And that would be, what if I am reassigning my value onto the outer scope? Well, that's not much of an issue. It just calls this one all the same. And that is pretty much it. Let's just check out the assembly code for this. Is it not? Okay. So the assembly would be, I construct it, I move it. And that move would be just called here, which is great. That's how it should work. Anyway, we just got stuck a little bit. I got confused because I was expecting this function to, inside of assembly, evaluate from foo to zoo, but somehow let's just do this. I'm just kind of curious about this. We are definitely not on the point here, and we are getting carried away. Zufu. It looks like the evaluation order of a function is unspecified. Wow. That is truly, truly. Let's see how to make sure in C++ that the function parameters are evaluated in order. Well, that's really bizarre, man. That is really bizarre. Using the curly brackets, we can avoid that. Utilize guaranteed ordering. Certain operators have a built-in... Yeah. Well, that's interesting. We might as well make a whole other video of the order of function parameters evaluation in C++ now that I think about it. It never crossed my mind this kind of stuff would happen. But yeah, there you go. Anyway, thank you for watching this video so much, and hopefully I'll see you soon. Take care. Bye.